Everyone talks about training AI models, but here's a little secret. That's not what's killing your performance or your budget. Let's talk about inference, the fun part where your model actually does something. Now, why exactly is inference so costly? Well, there's a few main culprits. To start with, the lack of optimized models for inference is a big issue, because many organizations are running models that are dramatically oversized for their use case. It's like bringing a huge toolbox to fix a single screw that was loose. You might be using a large language model when a specialized and smaller model would actually perform better, which would lower cost, increase performance, and perhaps improve accuracy too. Let's say though that you need a large model. So optimizing Llama 3.1 with 70 billion parameters would cut memory requirements in half. There's also the challenge of infrastructure optimization, because apart from the model itself, how you actually deploy it matters greatly. For example, language models use up huge amounts of RAM, so a proper inference runtime and engine can minimize these wasted resources. Your AI architecture choice might be creating unnecessary bottlenecks, and batch sizing, request catching, and resource allocation all play very crucial roles in inference performance. So let's start with some immediate optimizations. Quantization is your first stop. See, by reducing numerical precision of the model from FP32 to FP16 or int8 even further to int4, you can dramatically improve performance of the model with minimal accuracy loss. And this results in a smaller model size, which consumes less memory and can be deployed on less hardware. At Red Hat, we did over 500,000 evaluations of quantized Llama models, and we found that quantization can reduce model size by 3.5 times while keeping greater than 99% accuracy and speeding up model inference by 2.4 times. Next is proper batching, because processing AI predictions one at a time is incredibly inefficient. So optimizing your batch size for your specific hardware and use case can give you significant performance improvements with zero model changes. And runtimes such as vLLM automatically handle this for you at inference time. Also, don't overlook caching, because simple caching strategies can eliminate redundant computations. And this is especially important for applications with repeated queries or perhaps similar inputs. Let's talk more substantial improvements. Model optimization techniques like pruning and distillation can significantly reduce the model size while maintaining accuracy. You could think of it as a computational efficiency training, because you're removing some of the redundant parameters and streamlining inference paths. And when you combine these with quantization, the real magic happens. You get cheaper, faster, and equally as performant inference. Hardware optimization isn't just about buying faster or better GPUs. The key is matching your hardware to your actual inference patterns. Now, here's a practical roadmap. First, I encourage you to measure your current performance with your model. Get baseline metrics such as tokens per second and evaluations on model accuracy. Then start to identify specific bottlenecks, because you might not need to change the model at all, but instead optimize it. Next, you can start to implement some of those quick wins first. Quantization, batching, and caching are all important for efficient inferencing. Then finally, plan larger optimizations based on ROI. So you've learned how to help make model inference more cost efficient and improve performance, which can lower GPU and hardware needs and help you build AI-powered apps that respond lightning fast. But you don't need to rebuild everything at once. Start with these optimizations, measure your performance, and then scale from there. And remember, this is where Red Hat's flexible deployment options and enterprise support can really help to streamline your optimization journey. And it's all powered by open source.